waiting. I don't know. And then you just have to fill the scientific content. There will no bullshit generation. Just putting the tables and the figure and the reference, but it will be already saving quite some time. And we are working also on a remote software development kit, so for people which like to do more advanced stuff, they can program on their own computer codes and push to the platform, a bit like for people which are familiar with Git or SVN, you can do this kind of things. You can push and serve on your account. So what is the future of the big platform, or at least what we would like the big platform to be in the future, hopefully, is to host more biometric databases. So for instance, recently we have been given a new database by an institute in Brazil. They have collected an unofficial database on mobile phones, on different mobile phones, and they wanted to share this database and disseminate. They didn't have the opportunity to distribute this database themselves. So they gave us this database under a license agreement, and we could install this database in the platform. That is available now to run experiments. So we could do that with any database you are interested in, so you can put your database if you want. We like also to start organizing competition on the platform that is fully operational. Organize competition with the platform. And also, we like in the future to develop multiple backends. Backends, I mean computing backends. So for format, we only have CPUs. But we like also to provide backends which allows to submit programs for GPUs, also to submit executables and only code, because maybe some concern, for instance, for companies, they may not want to upload source code on the platform, but they still want to be able to use the potential of the platform to benchmark on databases and compare to others. So if we have the possibility to upload executables on the platform, then it will be we will be able to have an hybrid system environment that allows to run piece of codes which are in a given language, Python for instance, executables, and maybe MATLAB. We also think we'll have backend in MATLAB, although it will be not my preferred choice, because that's not true. Also, another wish is that we like, and we are actually already in contact with other institutions to install a copy of the big platform in their own, on their own infrastructure. In particular, institutions that have databases, they want to share, but they can't. They can't because of data protection regulations. But they want to have others to benefit from this data. So basically, we have contact with institutions, and it can be you, which have the same kind of needs. We can provide you, we'll be able to provide the code to install the platform, the documentation. It will have to be done under given license agreements, so that we don't that we controlled. And you will be able to deploy your own big platform with your own databases that you are not able to share. And finally, the ultimate dream of the big platform is to go with a federation of big platforms. So ideally, we like to be, if we have many big platforms which are different institutions and different databases that cannot be distributed, we like to find a way to connect, to interconnect all those platforms, so that users, researchers that use this federation of platforms can submit experiments wherever the data is. They don't have to figure out where the data, they know the data is available on the grid, okay? And it's just going to be executed where the data is, and you get the results. So this will be the ultimate dream, I would say, of all this business. So this will end my presentation. I would like to thank, in particular, all the researchers in my team at Idiap, and the engineers as well, that all worked out for 2 years. So you may not realize that this is 2 years of work, basically. But the project started in 2012, right? And with the design and so on. And it's 2 years of intensive programming, development by researchers and testing, development by engineers and testing by researchers. I'd like also to thank the partners of the eOpenSea project, because BIT is not only a platform, the outcome of a European research project called BIT as well. I'd like to thank my partners in the BIT project that have helped us to design the use case of the platform and to also help us, which are helping us to test it. So the University of Autonoma de Madrid, University of Surrey, Saint-François, which is partner to IT in Germany, and the Catholic University of Leuven in Belgium, which are taking care of all data protection aspects. Thank you for your attention. Thanks again to the Prime Chair for this opportunity, and thanks to the funding instruments. Thank you very much.
The audience should have some questions. Okay, this one's live. Good morning, Sebastian. I was wondering if you've looked at the issue of notebook classifiers, because if you put, say, FRGC online, the test set is available to the people submitting, and they can basically submit a notebook classifier which basically looks at the test set and checks everything, and then get an authenticated result that shows like 100% performance in FRGC that they can show to everybody else. And you probably couldn't detect what's being done within the algorithm. Obviously, you would go for 100%, but you can dial up any number you like. Have you considered, I suppose, anti-spoofing techniques?
So spoofing the techniques to detect the problems will be the reverse. People using bad databases.
That's right, so cheating basically.
Right, so here what we are going to have in the platform, as not mentioned, is that databases need to be provided with a protocol, or protocols, right? So as I say, you don't have access to the data, you just have a view of the database, and you can select the protocol you want to run against this database, right? So one of the problems we are mentioning is that if we put there databases that have been available for download already, people could have tuned beforehand hyperparameters before putting it there, right? But given that everything will be open, you will be, in the end, if someone shares the result of an experiment and makes public all the two-chain algorithms, anyone would be able to figure out the hyperparameters and may find out that there was some tuning, and we just decide to move some to another database because FRGC is now overtuned and there is no gain to make on it. Let's move to something else. So I think that it will be more this kind of situation that will happen is that at some point people realize that okay, this database now there is no progress that can be made. Let's move to something else.
Sorry, a slightly different question. If you know the test data set, it's like knowing the exam. You can just put a CRC check on every image and give back exactly the answer for any database that's been released to the public. So unless the test set has never been seen by anyone and no one knows what it is, you can get any performance you like by because you know the exam paper.
It might be difficult to implement this kind of thing because you don't know on which images you test. I mean, you just upload we design the research pipeline, and this pipeline is just going to be executed sequencing or in parallel on different samples, and you don't know what's the right target for the sample, right?
Well, you do if it's FRGC or something where it's released.
Well, no, you don't. On the platform, you don't have any information. You don't have any information on whether the particular images you are going to test is a genuine user or imposter. You don't have access to this information on the platform. The code doesn't have access to this kind of information. So it's not possible to tune directly by reusing the ground truth, so to say. It's not possible to cheat by accessing the ground truth because you don't have access to it.
Have a go.
Any other question?
Thank you, Sebastian. Excellent presentation. Will it be possible in the platform to optimize parameters? So, typical case in your experiment, biometrics is you have a system, you have an algorithm, you have some parameters you want to optimize. So, to run it iteratively, so you can optimize some parameters.
So yes, this is a feature we are working on at the moment. So everything to do it is there at the moment because you can anytime run an experiment by just changing hyperparameter, but it is a manual task. So we are working now on a way to say run this experiment for this range of values for those hyperparameters. basically. So we are working on it at the moment. We don't know if we are going to be able to implement it by January, because there are so many other things to implement.
Okay, anyone? In your big platform, is there any way for the researcher to find out the cost of, for example, I have a wrong recognition. I'm not sure whether the wrong recognition due to, for example, the face post problem for face recognition, or that the face is occluded. Right? Is there any way to access such information since I don't have the source?
Okay, so basically your question is there a way to analyze the data to understand where the algorithm is wrong? So the answer is no. So, I'll tell you why. So, by design, there is no way to access, as I say, the databases. But the thing is that all by law, according to the law, the legislation, the data protection regulations, all derivative data from raw data, including feature vectors, or statistical models, or biometric templates, okay, even if they are encrypted, are technically, legally considered as personal data. Okay, so therefore, you cannot access to it. The only things you will be able to access to are possibly the scores at the end. Okay, the matching scores, because they don't reveal any biometric information. So this is a limitation, but it has been done on purpose by design to be compliant with the data protection regulation. So if the only way would be that to install the platform on your own infrastructure, and then because it's your own infrastructure, you can go inside and it's your database and it's your infrastructure, it's your account, so you can go and try to do it. But so what we are going to do also with this remote SDK, we are going to give the opportunity to run locally, okay, on some toy datasets. So if you have some toy datasets and you have developed your toolchains, we are going to provide the framework to allow to execute in console mode to test your toolchain before sending it to the platform. So basically locally you can test it on any database you have, okay? But it will be up to you to do it. And here you will be able to analyze, but not on the platform. So if you want to do this kind of things, you have to develop a specific analyzer because the platform works that you start with the data, you have all the processing blocks, and it ends up with an analyzer which is very generic thing that can be just computing error rates or false accept, false reject, or whatever on the scores. But it also plots histograms, and you can also ask the platform, you can ask to be implemented in the platform's analyzer which are more clever, maybe, that are going to analyze a given criteria based on some ground truth in the data. But it will have to be pre-programmed. Okay.
Great presentation. Just one question. So, part of doing, right, like, part of running an experiment is managing the environment around it, right? So, have you thought of how you're going to maintain the code run? Because I move to the next library, my code doesn't work on it. All the citations that I have in my paper now start breaking because of that, and then I don't know any way to sort of fix that.
Okay, so we put in place a version control system. So basically, everything which is done on the platform, the toolchains, databases, codes, everything is under version control, under versioning. So let's take the example when I'm running an experiment, a given year, which I generate an attestation, okay, which has a given version, and let's say that 2 years later, for some reason, the platform has been upgraded, okay, and that particular toolchain that was executed before cannot be re-executed without modifications. Okay? That's part of life. There is nothing. The only thing that will have to be done is that the user or any user, so the author of this toolchain or any other person that have access to the toolchain because it's public, will be able to clone it and therefore make a new version, change the thing that has to be changed, and re-execute it to be re-attested. Okay? It will be the same scenario that if you change the database. For instance, you have an attestation for this database version 1.1, okay? And 2 years later you have a version 1.2 because you had to remove data or you have to patch the database. So which means that all the experiments that are being executed in this 1.1 version of the database are just attested on this 1.1 version of the database. If you want to have a new attestation that is work on the version 1.2 of the database, you have to run it again. But we are not planning to have an automatic way to re-execute all things each time you have an update of the database or incident, because it will just be well, impossible. Too many things to try. So it will have to be to rely on the users to do it on a case-by-case basis.
And we put just only one input signal or maybe image, get just one result and do it?
No, because you cannot output databases. So when you execute an experiment, you execute the experiment for the full database for a given protocol. So for instance, if there is a toy database, because this is what we're planning to, actually we do have, we have the AT&T database, which is toy in face recognition, which is very small because it just takes a few minutes to execute. Okay? So on this kind of database, you can have very quickly a result to validate your experiment before you go crazy and run it on a large scale.
I think it's